Hi, in this video we are going to go over the problem 23. This problem is a little different than the problem that we saw already. Here we have k lists. So in past we saw a problem that we only have two lists. So for example this one, and they were both increasing, and we wanted to merge them in a sorted fashion. But here we have k. So for example I have this one, and this. If k is 3, we can have more than 3. And we put all of them together, merge them to get an increasing sorted array. The first thing we do for in linked list, we define a node. So we give the value data, and the next is by default none. Then for example I here define the first one, the second one, and the third one. So at the end I have these three. Okay, before writing the function, so we know that the input to the function is going to be lists, and that has the heads that we define here, node A, node AA, and node AAA. Okay, let's write the function now. We say define merge k lists. Input is this one, and I have h equals l.data index for index and L in enumerate lists. Okay, what I'm doing here, I go over the lists, I read L and index, and I put them in H if it exists. Okay, so if I do that, let's see what I get. I'm going to say let's print that here, and let me just run this function. Just say return -1. Okay, so this is my H 3 4 1 2 2. So what is that? So 3 is the head of this linked list, and what is 0? 0 is index of that in this list. So I want to know which linked list that is related. I know that is related to linked list at index 0 of this list. So next one, 4 1. Which one is 4? So one of them is 4. That should be the head. So actually here, this is 4. You see here, this is 4, this is 6, this is 8. Okay, this is 4, and index is 1, and the third one is 2 2. This is head 2, and the index of this linked list is 2. Okay, so I have that H. So I have all of the heads of the linked list and also the index of their related list. Now I'm going to go and heapify that. I say heapq dot heapify H, and I'm going to print that after doing heapify. Let's do that, but to use this function I need to import that. I say import heapq. Okay, let's do that. Okay, now I have a heapified H, and you see this is 2 2 comes first. Why? Because it is based on the first element. So the minimum value will be this one. Okay, and this is just the index of that list, just to know which list that belongs to. But this is that matters. So you see this came at first because that is the minimum. Okay, now let's me define this prev value here. So I also define a node for that. Prehead equals prev equals node. We can give a value to that -1. So I define something here, and then I'm going to go over a while loop. I say while H. I get two things out of the our heap, and say, let's say data and index, because those are the things that we recorded here, if you remember. Okay, So those things are heap q dot heap pop. What is the name of our heap here? H. Okay, so you can also print them to see what are those things. Okay, prev dot next equals lists IDEX. So I need to, for example, for the first one, let's see what happens. So let's say IDEX here is 2. Is that correct? Because this is the minimum. We take that out, data will be 2, IDEX is 2. So I'm going to refer this to that 2, to this one. So arrow should come here. First we visit this. First we add this to our linked list, to the giant merge linked list. I need to add this because this has the minimum 1. So I need its index. So that is, I need to know which linked list is that. That is the index 2. That is here. So I'm here. So I want to decide to which direction I should go. This one, or this one. I go this one because it has the minimum. But when I find the minimum 2, I need to know the index to refer to that. The index that comes here. Okay. Now prev next refers to that. Then we go one step ahead for the prev. Prev equals prev dot next. And because we visit this one, we have to move that index one step ahead, like this. Okay. So I come and say lists IDEX equals lists IDEX dot next. Okay. The other thing that I need to do is that if lists IDEX if that exists, if it is not none, what I do is this. So I say heap q dot heap push h I'm going to add that to the heap. So I add its. Now it's 1. You see, this was L3 here. Now I move the L3 here. Okay. Now I have to have the information of this node to that heap that I'm comparing. So for doing that, I put its data and index of the list to the heap. At the beginning, we had these 3. We had 3, 4, 2. We had 3, 4, 2. Now I realize, okay, this is the minimum, and I need to go forward one step here. When I'm here, for the next comparison, I need to add this information of this here to that heap that I need for the next comparison. Okay, I do that here. And if we do that, let's also print h to see what we have. And at the end, I just need to return the prehead.next, which is the beginning of my new merge linked list, and see what happens. Okay. Okay. So we had that initial 3 linked list. We heapified that. Okay. Then I popped out this one, 2, 2. This. And what is added to that? You see 7, 2. 7 added, and index of that is 2. Okay, now I'm comparing this, and 7. Which one is minimum? This one is minimum. Oh, okay, this one is minimum, so I need to pop this one. 3, 0. So I come and say, okay, 3, 0 is out. So I move this one forward, the pointer of that, and I add that value to the list. So I should add 4, 0, which is added here because the index is 0. Now I take out 4, 0. I take out this one, okay, because 4 4 7, this is still minimum. I take out that one, heap pop that one, and when we do that, this is not a pop left, this is a just pop because we remove the node. So if I do that, this moves one step ahead, okay. And what is added? 9 0 9 0 here. What is the minimum? 4 1, this one. Now L2 moves forward. What is added? 6 1 6 1 is added. Now 6 is the minimum, so I take this one out. What do I add? 8 1 8 1 is added here. Which one is minimum? 7 2 7 is here. I move this one forward. So what do I add? Nothing, because that is none. I don't add it. Do I add anything here? Do I add none? No, because here you see the if that is not none we add. Now it is none. I don't add anything. I'm talking about here. I don't add anything for when L3 is here. I go for the next small one. What is the next small one? 8 1. That's here. I move L2 here. Okay. Do I add anything to the list? No, because that is this condition. That doesn't add anything. We are none now. At the end, we pop the last one. And while we are doing that, so they all get connected, and we end up having the correct merged linked list. Now let's print them. Okay, now I'm just printing them in a nice format. So I have the node A as my first linked list. I have node AA as my second, and node AAA as my third list. And then I use the function that this list, if you remember, is this one. Let me take that and put it here. Okay, that has 3 nodes, and at the end I'm just printing the result. Okay, so let's do that. Okay, so this is the result. So I have this one at the beginning, this one and this one, and this is the result of that. And you see that is increasing. Okay. Heapify is order of k here because we only have k values. Let's see what else we have. You also have one heap push here. For example, here we have a heap push. What is that one? So that is log of k. That is the insertion time complexity that we have. What else I have? I have a while loop, which is order of n. Okay. Also, I have here making a list at the beginning that is order of k. So this is order of k. Here I have heapify order of k. I'm in a while loop order of n. Do you have anything else? No. Here order of k. Okay. So the time complexity is n log k. Because this we can ignore this. This is technically plus n log k, but because k is smaller than a, we ignore that. So it's n log k. And the space complexity is order of k. Because I made that list here that is gonna take k spots, and then after we heapify that, still that is k, and throughout the algorithm it always remained k or less than k, so it's not gonna go over that. Whenever we heap pop, in all of the loops we do that, and sometimes we just push inside, so it's always less than k. Okay, that's the solution of the problem 23. So this was very similar to the previous problem that we used linked list, but here beside using linked list we also used priority queue, and priority queue helped us to find which heading has the minimum, and that is saving a lot of time for us because we don't have to go and search all of them. That automatically gives us the minimum one. Thank you so much for watching this video.